Okay, so after this, you're going to basically, this is what you're going to do at the end of the day today. Draw a DT graph and description. I will tell you, it's kind of like yesterday in that little ladybug assignment where the kid was waiting to see the principal, pacing back and forth, right? Sort of like that kind of thing. That was sort of a lead into this kind of. So hopefully you remember that movement to the right. Okay? Close your eyes. Oh. Movement to the right is a positive slope, right? Oh no, hang on, that's not the one that's supposed to be moving. This is the one. Movement to the right is a positive slope. Do you guys have that picture right there?
No.
What do you guys have? Oh yeah, okay. So draw the picture, right? When the car is moving to the right, it's a positive slope, sloping up and to the right. And of course, movement to the left would be a negative slope. Now you'll notice that in this one here, my frame of reference, my origin, is usually marked with a 0 there. You'll notice that this one here starts way up there. Does it have to be up there?
No.
Does anyone want to join Lane on the no wire? You'll go too? Anyone else? Does the line have to start up? Can I assign it a point just so we can talk about it? Let's say that it's at plus 10, just so we can talk about it. Does that have to start at plus 10? I mean, it could be plus 12, right? It doesn't matter what the number is. No? Why not? What does that really mean in terms of the car and where it is? How far it is from the origin. So in this case here, where is, let me just make the green car a little smaller so I got some more space. Where is the line, the start line, the origin? To the left or the right of the car? The 10 is plus 10. 10 to the right of the 0. So where is the 0 line? Yes, exactly. There it is there, right? Kind of did it. I'll put it like that. So there's 0, and there's plus 10. But does it have to be there? Like some people might actually say, well, where it starts should be 0, and if the car is moving to the left, then, and if you started the car at 0, where would the blue graph line be? It'd be down like that, right? That's all I'm getting at here. You don't have to start there. This shape could be anywhere on the graph. It's the shape that tells me that it's moving to the left.
So was I right?
Were you?
I don't know.
After all that, then you say, was I right?
Yeah.
Was Lane right? What was the question that I asked that he answered no to? I said, does it have to start at 10?
No.
No, it doesn't. It could certainly start down anywhere. Like if it starts at, most people would put it at 0 there, right? But I've got it there. Now, remember that these are both, and you'll notice that I've got it in big, bold, capital letters, constant velocity. I'm struggling with my grade 12s right now over their understanding of the difference between constant velocity and accelerated motion. Constant velocity means what?
Constant.
What does it mean? Come on, don't just repeat the words back. It stays the same. Like if you're driving your car and you set it at cruise at 100, it's 100 from here to wherever you're going. Right? If it's accelerating, then it's speeding up and or slowing down. Right? So these are both examples of constant velocity. How can I tell from the graph that it's constant velocity? Straight line. Flat line. Of all the people. Is it? That you have? Oh, what are you Googling? Whether what?
The water is like a oil.
Oh, why are you doing it now? Why are you doing it now? Maybe later. Teachers are in a heightened awareness of cell phones, and especially those people that are sitting with clear view of the door. You understand, right? Yes, thank you. Okay, so constant velocity. Okay, good. What about speeding up and slowing down? Now, what do you guys have for a picture? Oh, you got some little cars there zipping around, right? Okay, so accelerating to the right. The car is, how can you tell it is accelerating to the right?
There's a car that points to the right and one up.
It's going plus
On
positive.
0 to 8, there's 7.
There, that's the word I'm looking for. The cars are getting farther apart, right? Each picture of the car is, here's 0, 1 second, 2 seconds, 3 seconds. The distances that they are apart is getting wider. We know this means the car is speeding up. If you were a cartoonist back in the 50s and you were drawing Bugs Bunny speeding up, you would have to draw them farther and farther apart to make it look like that when they put all those pictures together. What's the graph going to look like, my friends? Upwards curve.
No, maybe other way.
Other way? You want me to do that?
Yes.
Okay, go ahead, put that in there, you're right. There's not really a spot, there's a spot on the side that I want you to do it. I guess you have to draw the actual graph axis there, right? Okay, so that is indeed accelerating to the right. What if we are slowing down to the right? Here, the car, how can we tell the car is slowing down?
And cars are getting closer.
Cars are getting close together, exactly. And you all spotted it like so, right? I'm going to get you to write in a description about the steepness. How would you describe the steepness of the slope here? Slope getting steeper, right? Had a hard time getting that out. Slope getting steeper. And when I say steeper, like there it's kind of flat, steeper, even steeper, right? Yeah? Okay, so Lance, what would you say about the steepness of this one down here, slowing down? What would you say about the steepness here? Okay? Evens out. Oh, this one's getting steeper. What would you say about this one? When you say evens out, I think I know what you're saying, but I don't know if that's the best description. The opposite, right? I'm just thinking of a word that starts with F. Flatter. Slope getting flatter. Again, all DT graphs. And why am I emphasizing that, do you think?
People forget.
Yeah, it's because there's another type of graph coming up that's different that you have to sort of be able to deal with. So I want to ensure that you understand these are all true for DT graphs. Okay, now I think here you get to draw your little car.
No.
Yes, you can draw it as fancy or as non-fancy as you want. If you want to put an X, be my guest. But show the car slowing down, sorry, accelerating to the left and slowing down to the left. Go ahead, say it, Billy. I'm going to do my tenants while you guys do. Do I have the picture? No, I don't. I have to draw? I'll do an X, yeah. I was going to copy and paste, but this part, can I ungroup here? Well, maybe I can ungroup. No, I can't even ungroup. Okay, so accelerating to the left would mean that it's getting further apart, exactly. So I'll draw my car here. Yeah, that is a bad car. Hey? You can tell why I'm not teaching art class. Okay, so now where should I draw the next one? Like that went one spot, maybe 14. I guess I should have it at this is at the start, right? So this guy here should be right there. So 14, and then maybe like 10. Oh no. Yeah, maybe 8, right? Okay, good.
0.
Okay, accelerating to the left, right? What's the graph going to look like? Did you draw a graph?
Yeah.
Oh, I didn't draw.
I hope you drew it in pencil. It's accelerating to the left, so that means that the slope must be
It's gonna be negative.
steeper. Is it to the right of the origin?
No.
These are all positive values, so which means it's starting where? No, it's starting in the positive. That's why I moved that down. And it's speeding up, getting steeper. Did you draw
No, I did not draw.
Yeah.
that?
I did not.
If your neighbor did that, give them a congratulations.
That's for accelerating.
Accelerating to the left. Slowing down to the left. Let's bring my car back in here. Slowing down would mean that it would have to be far apart at the start, right? I guess it doesn't have to be, but... something like that. So what now? Again, is it in the positive region?
Yeah.
It is, so it's going to have to be above. And slowing down means slope getting flatter. Slope getting flatter. So what's that going to look like?
The opposite.
The opposite of that? Are you saying this? Give yourself or your neighbor a congratulations if you got that right. Okay, let's have, Graham, you wanted to be my helper today, right?
Oh, yeah.
All right, okay, so Graham's going to get a chance to move the car here. He's going to get to play with Hot Wheels, really. That's what I boiled down to. Cool Hot Wheels, all right? Now, at the end here, you probably can't see it very well. Let me get my basement lamp out of the way here. I have right here a little device, and what it does, it sends out sound. You're going to hear it when I turn on. It'll go tick, 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 tick. It's kind of like a dolphin. And, except it doesn't swim, and it's...
That's a good dolphin.
Yeah. The sonar part, yeah, exactly. So what it does is it sends out a sound wave, and it bounces off the cart, and it comes back, and it knows the speed of sound. It's 330 meters per second. And it can figure out, based on the time it takes to come back, how far away it is. And it does that like every 1/200th of a second.
Can it move the car?
No, it can't move the car. You have to move the car. But it can tell you where the car is, and then it's going to make a graph up here on our screen. Okay? And this is what it's going to look like right here. Okay, it's going to make us a graph here, okay? Before we do that, though, I want you to take a guess. Now, you have to flip the page, right? If you haven't flipped the page, you should do so. There are 3 little spots there. It says, for each description, determine what the each graph will look like. The card moves to the right and then immediately to the left. Underneath guess, I want you to draw a little graph of what you think it's going to be. So you've got 3 guesses to make. Okay, go ahead, and then Graham's going to come do them for us. So make those 3 guesses. No, it's not bad. It's not bad. He stopped for 2. Well, his reaction time was quite long here, right? But basically, that's what you got, right? So it's left, pause, left. That's what you should be writing down, right? Left, pause, left. You did fine. Okay, let's look at the next one. Oh. Ah! I closed the whole thing. Here we go. Take 1. Is that good? Or is that backwards? I think it's backwards now. Isn't it supposed to be slow at the end and fast at the start?
No.
Isn't it?
Yeah.
Yeah, slow at the end, right? Because the slope is flatter at the start. Let's try again. Listen for the click, click. You did backwards again. Fast at the start, slow at the end. Hang on. Okay. No, I restart.
I think this could be this fire.
Guess you just volunteered to be next. Ready?
Your finger's in the way of it.
Okay, you know what? The other, I realized what was causing Billy's. I wasn't zoomed in enough. That's why yours wasn't.
Stop the beginning, slow at the end.
Like he said.
Don't forget.
There, I needed to zoom in. That's why it wasn't looking good for you. Okay, ready?
Why isn't it going?
Almost good.
Not giving it.
You might also be, actually, you know what? Which way are you going first? Okay, so it might, the faster I make it go, the less the range is. So start over here. Get it started a little closer. That might work better. You reduce the range by going at a faster rate. Okay, ready? Okay, now I gotta zoom out. How do you do? Oh,
Oh, that's pretty good.
that's not bad. There we go, right? So fast at the start, slow at the end. Good. Right? It's not easy up here, is it? Left is the new right, fast, slow, all that complicated stuff. Okay, Lane? Hey,
Yeah.
we've had a strong male representation up here. Anyone, ladies? It's always the guys that want to come play with the card. Nick? Okay, come on. What's the last one?
Right.
Okay, so no, it's right slow.
Yeah.
Right slow, then faster, then stop, and then back really slow.
So,
So slow, fast, stop, backwards, right?
Right, slow.
yeah, just putting it in reverse.
Yeah, put it in reverse.
So left, faster, left, and then
Lead.
right.
Yeah.
Right, slow, then fast, pause, flip.
Okay, ready? Okay, I'm gonna have to zoom out a bit here. How was that? Close enough? Gonna give it to him? Yeah, I guess. Okay. In all of these situations, everything was above zero. Why is that? Because this is where zero is, and where's negative? Everything back here where the track doesn't exist, right? So everything has to be above. What would be the only way? Is there any way I could show negative on the graph? Like, would that work?
Yeah.
It would still just show the distance away, not the displacement, right? This thing doesn't know which direction it's pointing. It just knows there's an object there and it tells you how far away. So there is no way ever to get down into this area. Just as a little aside. Okay, we've had a little fun here. Now time for you to sort of practice a little bit. There are 5 little situations there. There's plenty of white space for you. I'm going to give you like, no, I'm thinking about like 8 minutes. Okay? And then we're going to check those, and then this last page here, you're going to pull off, you're going to put your name on it, and you're going to give it to me before you leave. Because I want to see what you know. So do those 5, I'm going to put a timer up, you got 8 minutes, and then we're going to check them. And if you want to work with someone, you can. Perfectly all right. Let's do these quick, and then you got a few minutes to finish up. A ball is thrown up in the air, it lands on the ground at your feet 10 seconds later. Position is measured vertically. In other words, we're measuring how high it goes. So it's going up, and the amount that on the way up, the amount that it goes up should be slowing down, right? So it should be getting closer and closer together. So you should have something like that, right? This is time, and this is height. So it slows down on the way up, speeds up on the way down. It lands on the ground at your feet. How come it's not landing right there? How come it's not like that? Because time is on the bottom, right? Guys, can we look at this one? Can we look at the answers? I seriously don't need more than about 3 minutes to do this, and then you'll get a chance. What if position was measured in the above example horizontally? I didn't measure the height, I measured the left and right. When you throw something straight up, how far sideways does it go? It doesn't go anywhere. What's it going to look like? We're measuring horizontal distance from you. It'd be a flat line at 0. Well done. Not an easy one. Flat line at 0. Because we're measuring the distance away from you, and I throw it up, right? The entire time it's still 0. A man walks for 8 minutes towards the south from his home on Main Street North to the Royal Bank, spends 2 minutes at the ATM, and then returns home. The key here is which one is the origin, home or the Royal Bank? Most people say home because that's where he starts. So he's walking south, which is negative,
That's a rude.
generally at a constant rate. Yours doesn't say south?
No.
Oh,
Just say-
okay. Okay, I'll have to add that in.
You got it right
And then he spends 2 minutes at the ATM, so flat, and then returns home. Maybe a little bit slower because he's got thousands of dollars with him. Or maybe faster because he's got thousands of dollars with him. I don't know.
Well, we did that, but on.
You did it like this?
We did not. Yeah.
No.
No. Yeah.
Yeah.
Okay. That would be okay if south was positive.
Myself wasn't even there, so.
Okay, fair enough.
So we got it right.
Okay. A bowling ball spends 8 minutes in the rack waiting to be thrown, then takes 4 seconds for the ball to reach the pins, then 20 seconds to return. Again, which is the origin? The rack or the pins? Most people say where it starts. So it spends 8 minutes sitting there, really long line, doing nothing. 4 seconds to go to the other end, basically straight line up, and then 20 seconds to come back, right? Not to scale. Not even close to scale.
Yeah.
Girl leaves her locker by the office, starts to walk to the gym. She walks 15 meters before she forgot her gym clothes. Returns to the locker, gets the clothes, proceeds to the gym. Again, locker is likely to be 0. She's walking to the gym. She walks 15 meters. She realizes she forgot. She turns around, goes back to her locker, gets them out, and then, because now she's late, goes quickly to the gym. Are you kidding me? People forget their pencils coming to my class all the time. Yeah, I know. Okay. I want that handed in before you leave. Go quick.
Henry